It is commonly held that there are four states of matter. Matter exists as a solid, or as a liquid, a gas, or in the fourth state of matter, as plasma. But we're much more familiar with plasma as the brilliant arc present when metals are joined using the tungsten inert gas method. The TIG arc is actually plasma, an ionized gas that can conduct electricity, the fourth state of matter. Plasma for cutting is created by adding energy to an electrically neutral gas. In our case, the gas is compressed air, and the energy is electricity. With the addition of energy, the gas is electrically imbalanced, and, like wire, will conduct electricity. It is now plasma, and like the wire element in a light bulb, the more electrical energy we push through it, the hotter it becomes. By controlling the plasma, concentrating it into a small area, adding air pressure, intensifying with higher voltage, we've created an arc to do more than melt metal. An arc to blast through and blow the cuttings away. Put simply, we'll be performing plasma arc cutting. And if we tilt the plasma arc torch, we'll be performing plasma arc gouging. With a plasma cutting power source, a plasma torch, adequate compressed air, and electrical power, we can rapidly and precisely cut or pierce any electrically conductive material without preheating and with little or no heat-affected zone. Yes, aluminum, stainless steel, brass, copper, and even titanium are included. Or should the need ever arise, all simultaneously? And as you can see, plasma cutting provides the solution to cutting stacked material. Here's the equipment you'll need for air plasma cutting. First, a power source designed for plasma cutting. Typical models range from 12-amp systems that will sever quarter-inch mild steel to heavy-duty industrial models with 100-amp and greater output and the ability to cut inch-and-a-quarter material. Input power requirement will vary from a simple household wall outlet to three-phase AC power. The development of the plasma cutting torch is one key to the success of the process. Its components shape and constrict a high-pressure air stream to a very small diameter. This stream, when ionized, becomes the plasma that will conduct electricity at the current and voltage level required to cut metal. Removal of the torch shield cup reveals internal torch components. They consist of a tip and an electrode. These two parts comprise the most common consumables of the plasma cutting system. Other parts include the swirl ring, designed to shape the compressed air, and an epoxy cup to enclose the parts. A standoff or drag shield may also be included. When the torch trigger is depressed, the arc is started in one of two ways. First, high-frequency start. A brief high-frequency pilot arc jumps the gap between two components within the torch tip and electrode. Or second, by a pilot arc created as one internal torch component briefly contacts another, causing a very brief short circuit. Pilot arcs, maintained as electricity flows between the tip and electrode, start the airstream ionization process and the creation of plasma. At this point, the plasma arc emanates from the electrode. Current is conducted by plasma between the electrode and the workpiece through the hole in the torch tip. The arc's heat is transferred to the workpiece. At the point of arc contact, metal is simply liquefied, melted, and blown clear. Air plasma cutting and gouging requires a regulated supply of compressed air. To protect the regulator, it is sometimes mounted within the power source enclosure. Pressure will vary from 50 to 90 psi, depending on the plasma system in use and the torch lead length. The compressor must have adequate capacity to maintain the required pressure during the duration of the cut. Clean, oil, and moisture-free air is vital to the process and to the life of consumables. Servicing the air filter regulator should be included in your maintenance schedule. Safety equipment and clothing requirements for air plasma are about the same as they are for welding. Full-face helmets or face shields are acceptable for eye protection. Filter shade density can be selected on the basis of power source amperage. Consult the owner's manual for recommendations. There are some special safety considerations with plasma. Heat from a plasma arc can cause severe burns. Plasma arcs reach well over 20,000 degrees Celsius. Point the torch away from your body when starting the arc. This intensely hot and powerful arc can quickly cut through clothing, gloves, and tissue. Just as with welding, a complete electrical circuit is present from the power source and torch through the arc if cutting, through the workpiece clamp and cable, and back to the power source. However, plasma cutting requires much higher voltages than welding. For your own and others' safety, always set the power switch to off before installing or moving the workpiece clamp. Set the power switch to off before dismantling the torch. In addition, do not remove or allow to be removed the workpiece clamp while cutting. Plasma cutting produces molten metal. It's extremely hot. Before starting the cut, make sure that sparks will not fall or be blown toward flammable materials. Plasma cutting leaves a very narrow heat-affected zone, but it still leaves one. The cut material is hot. Use caution. The torch tip may be very hot after cutting, even though some manufacturers include timed post-flow cooling. Allow adequate cool-down time before working on the torch. Air plasma cutting is really very simple. Assuming you're wearing personal safety equipment, the power source is connected, and the compressor air supply is on, here's the routine. Check the torch tip, electrode, and retaining cup to assure they are assembled appropriately and free of debris. Check air pressure on the power source or at the remote filter regulator. Set the power source controls. Your manual should provide some suggested settings. Be sure to read and understand any notes provided with the chart. Switch the power source to on. If your amperage is set above 40 amps, position the tip of the torch the manufacturer's recommended distance above and at the edge of the material to be cut. If amperage is less than 40 amps, the tip may be set in contact with the workpiece. The cut can be made by either pulling or pushing the torch on the line to be cut. Depress the trigger to start the pilot arc. You'll know when the cutting arc starts. When it does, slowly move the torch across the arc, maintaining the required gap between the torch tip and the metal. Maintaining the gap may be the most difficult part of the procedure. You'll know your cutting speed is right if the sparks go through the metal and out the bottom of the cut. Adjust your travel speed if excess dross is present at the bottom of the cut. If the arc does not penetrate the metal or the travel speed is exceptionally slow, extinguish the arc by releasing the trigger. Then, make the necessary amperage adjustments and start again. Attempt to correct the problem by assuring that the workpiece clamp is secure and close to the cut, assuring that consumables are not worn and are installed correctly, adjusting air pressure, and/or adjusting the power source amperage. If your cutting speed is too fast, molten metal will splash back upward and possibly short-circuit the tip and electrode. If the torch tip should accidentally touch the workpiece while cutting thick material, a high-current double arc could occur within the torch as the arc finds a path of less resistance between the torch tip through the side of the electrode and down to the workpiece. Double arcing could at worst destroy and at best shorten the life of the tip and electrode. Remember though, depending on the power source and when cutting requires less than 40 amps, the torch tip may touch the workpiece, providing the material will cut without causing splashback. Finally, at the end of a successful cut, pause briefly to allow the pieces to separate completely before releasing the trigger. To preserve consumables and to make the process even simpler, some systems manufacturers provide a standoff or drag shield to automatically hold the gap between the torch tip and the workpiece. Both the tip and the electrode may require changing to accommodate the drag shield. To cut using the drag shield, set the torch directly on the metal to be cut with the drag shield orifice just over the workpiece edge. Depress the trigger and drag or push the torch with the drag shield lightly contacting the workpiece. Hole piercing requires a slight change in technique. To protect your consumables, Start cutting by tilting the torch tip or drag shield about 20 degrees from the workpiece. Start the arc. Notice that molten material is blown away from the torch. As penetration proceeds, tilt the torch to follow. When penetration is complete, proceed as if cutting. Air plasma gouging may be performed using the same power source and torch, but parts of the torch must be changed. The drag shield and the standard tip must be replaced with a special gouge tip and a gouge shield. Note that they are shaped differently. The orifices are larger than on the components replaced. The arc will be larger. There may be less air pressure. Set the power source and air controls to the recommended position. Start the arc and proceed to gouge with the torch tilted at 40 to 45 degrees to the workpiece. Holding the torch at that angle, push the torch into the gouged area while blowing material out of the gouge. Just as with cutting, any electrically conductive material can be easily gouged. Earlier, we talked about consumables. First, remember to turn the power source off before checking the torch parts. Although the retaining cup, swirl ring, drag shield, and O-ring are considered consumables and may need replacement if damaged or plugged, the primary consumables are the tip and the electrode. The torch tip is a precisely machined copper element with a tiny, absolutely round and concentric hole through the smaller end. If this hole is out of round, oval-shaped, or oversize, replace it with a new one. If the inside of the tip is not shiny and bright, clean it with steel wool. Be sure to remove all particles of steel wool when complete. The electrode is also a precisely machined copper part. At its center, a tiny rod of a rare metal called hafnium has been embedded. The plasma arc emanates from this material. If the hafnium is pitted more than 1/16 inch or 1.5 millimeters, remove and replace the electrode. When reassembling the torch, the swirl ring must be positioned as specified in the operator's manual. Here's a list of practices that will contribute to erosion of consumable tips and electrodes. Dirty and/or moist compressed air is high on the list. A major contributor is the simple act of starting the arc. Cutting grill work or expanded metal will require frequent or constant pilot arc presence, limiting consumable life. On the other hand, long, steady, controlled cuts contribute to extended life. Remember, consumable life is directly related to compressed air quality and to the cutting methods used. Air plasma cutting will probably never completely replace oxyfuel, but plasma's advantages should be considered for your cutting and gouging applications. Plasma is safer. There are no flammable gases. There are no flashbacks or danger of explosion. Plasma cuts faster. Preheat is not required. Plasma cutting leaves a much smaller heat-affected zone. Plasma hole piercing is easier. Again, because preheat is not required. Plasma cuts stainless and aluminum. In fact, any electrically conductive material. Plasma cuts stacked materials. The Miller Spectrum series of air plasma cutting systems includes a system that may well provide the solution to most of your metal cutting requirements.